Okay, welcome to another deep dive. We recently received some really fascinating source material from you.
Yeah, it highlighted a connection that, well, wasn't immediately obvious, I'd say.
Definitely not. It's the kind of thing that makes you stop and think, wait, what?
Exactly. Calculus and food spoilage.
Pretty much. So, based specifically on the sources you shared, we are diving into this relationship between mathematics focusing on differentiation and integration and food security.
Specifically looking at nutrient degradation while food's in storage.
Right. Calculus on one hand, keeping your apples fresh on the other, it does sound like two totally different worlds.
It really does.
So, our mission here for this deep dive is to unpack exactly what your sources are suggesting about this link.
Yeah.
How do these things connect? Why does it matter?
Let's get into it. The material you sent basically argues there is a tangible link here.
Yeah.
One worth looking at closely.
Uh-huh.
Between these specific math tools and how nutrients break down in stored food. And that fits into the whole food security picture.
Okay, so the sources aren't necessarily throwing complex equations at us, but they're saying the ideas behind calculus are relevant here.
Right.
And I guess when you think about nutrients degrading, it's not instant, right? It happens gradually over time. It's a process.
Precisely. And that's where the calculus concepts fit in. Differentiation, fundamentally, it's about rates of change, how fast something is happening at a particular instant.
Okay.
So applied here, it could model the instantaneous rate a nutrient is degrading,
Mhm.
like how quickly vitamin C is disappearing from those stored oranges right now, given the temperature and humidity.
Got it. So differentiation is the how fast is it dropping part.
Yeah, the speed of that loss at any given moment. And then integration.
Yeah.
Well, that's the other side of the coin. It's sort of the reverse.
Right.
If you can model that rate of decay, the speed, using differentiation, then integration lets you essentially add it all up.
Add it up.
Yeah, calculate the total amount of that nutrient lost over a specific time, from harvest to the shelf or even sitting in your fridge.
Ah, okay. So if I know the vitamin C loss speeds up when the orange is warm and slows down when it's cold,
Right.
that changing rate is the differentiation bit.
Exactly. And integration lets you sum up all those little changes over, say, a week to figure out the total vitamin C that's gone by the end.
Mm.
The source seems to really emphasize understanding both the dynamic rates and the cumulative loss.
Okay, and according to your source, this isn't just like a neat math trick. It has real applications.
That's the implication, yes. By modeling this mathematically, you get tools to predict things
Mm.
and to optimize.
Like what could you do with that?
Well, the source suggests you could, for instance, predict shelf life more accurately based on hitting a certain nutritional level, not just avoiding visible rot.
Oh, interesting.
Or you could simulate different scenarios. How would changing the transport temperature affect vitamin retention? Which packaging works best? That kind of thing.
So understanding the rate and the total loss using these calculus ideas, it actually helps make practical choices. Decisions about supply chains, storage conditions, all to keep more nutrients in the food.
That's the connection the source makes. It ties directly into minimizing nutrient loss.
And that links back to food security.
Exactly, because food security isn't only about having enough food, enough calories, it's also about access to nutritious food.
Right. Makes sense.
So if you can use these models to reduce nutrient loss during storage and transport, the food that actually reaches people is, well, better for them. It contributes more to tackling actual nutritional insecurity.
Wow. So these fairly abstract math concepts are actually giving us a way to analyze and improve something very real world, very practical.
It really shows how mathematical modeling can be, surprisingly versatile,
Yeah.
a powerful lens for understanding complex processes that unfold over time.
Okay, so to quickly recap what we found in your sources, calculus concepts, differentiation, and integration, they give us a framework, a way to grasp and measure how nutrients degrade in stored food over time.
And that provides tools to optimize storage, improve supply chains, and ultimately help preserve the nutritional value, contributing to better food security.
It's quite a connection. It shows how these mathematical tools can analyze these complex hidden processes, like, the vitamins slowly breaking down inside that fruit in the warehouse.
Makes you wonder, doesn't it? Where else is this kind of seemingly abstract math quietly working away, helping solve practical problems we see every day?
Definitely food for thought. Thank you so much for sending this material our way and sparking this deep dive. It was genuinely surprising.